On today's episode, China's retail giant goes to space, Boeing Starliner preps for its first crewed launch, NASA has a plan to save Voyager 1, and a new HIV drug created in orbit. China's rocket makers and online retailers are teaming up to bring drop shipping to a higher level, outer space. And this could open up a world of possibilities for both China's economy and their military as well. Chinese rocket company SpaceX is designing a system to replace cargo planes and ships with suborbital reusable rockets. On March 31st, the commercial rocket startup announced on their social media accounts that they had come to an agreement with online shopping platform Taobao, which is owned by Chinese retail giant Alibaba. Alibaba confirmed the agreement in their own statement, saying, quote, "Many great endeavors seem like a joke at first." The idea is for SpaceX to design a reusable rocket that will haul up to 10 tons of cargo in a container with 120 cubic meters of internal volume. According to a post on WeChat, the rocket cargo might include items as large as a car or a small-sized lorry. This vehicle will then be used to quickly and cheaply transport goods from launch pad to landing pad anywhere in the world, with delivery times being cut down to just 1 hour. You might recognize this plan as being very similar to SpaceX and their point-to-point cargo variant of Starship, a project currently being funded by the US military, with the hope that Starship can be used for supply drops into disaster areas or even active combat zones. The Beijing-based SpaceX has been developing a very Starship-like vehicle for the last couple of years and progressed to static fire tests of their methane-powered engines in 2023, so it's not like they don't have something solid to show investors. Their rocket prototype, the Yuanqing 1, has even completed offshore recovery tests already, landing the company over $27 million in funding last November. There is a problem here that needs to be considered, and it's going to affect SpaceX as well. Transporting goods through space takes a degree of special handling that doesn't exist with conventional shipping. Most products are not built to handle the shaking force of a rocket on liftoff or the brutal vacuum of space, so the cargo containers will have to be made to both isolate the interior from the force of the engines and to seal completely against decompression. And then there's the logistics of building landing pads everywhere Taobao will need them. The company is a consumer-to-consumer retail service that allows users to set up shops and sell using fixed prices or auctions like eBay, so the shipping needs and locations will vary quite a bit. For this reason, SpaceX expects to begin rocket delivery tests next year and has reportedly said that they believe their goals will be difficult to reach in the short term, so even though they're already testing their hardware, it does look like SpaceX is being realistic about the whole testing process for this unique project. This endeavor comes at a time of rapid expansion of the Chinese commercial space sector, thanks in part to government leadership calling for expansion of funding. It definitely sounds like a wild idea, but with the right funding, it might just be possible. After budget issues, delays, and hardware flaws, Boeing's Starliner capsule is finally being prepped for its first crewed mission launch, and we've been told to expect success, but not perfection. This will be the third launch so far for the troubled spacecraft. The crewed flight test is due to take off from Space Launch Complex 41 at the Kennedy Space Center no earlier than May 1st. The capsule itself was fueled almost 2 weeks ago and is in the process of being mated to a ULA-built Atlas V rocket. The mission is to take 2 astronauts, Butch Wilmore and Sonny Williams, up to the International Space Station for an 8-day stay. While on the way up, the crew will do a shakedown of the capsule's systems, focusing on things that couldn't have been tested during the previous 2 automated flights, like the reaction control system. Wilmore has made sure to set proper expectations for what we're going to see on this mission, saying, quote, "The expectation from the media should not be perfection. This is a test flight. Flying and operating in space is hard, it's really hard, and we are going to find some stuff. That's expected. It's the first flight where we are integrating the full capabilities of this spacecraft." The Starliner has almost 50 RCS thrusters, making it incredibly maneuverable. Wilmore, who trained on an extremely accurate simulator of the capsule to prepare for his upcoming mission, joked that he could, quote, "do a barrel roll around the space station if he wanted to." Unlike the SpaceX Crew Dragon, Starliner actually has physical controls and an airplane-style flight stick instead of a purely touchscreen interface. The crew will be performing some tamer manual controls in orbit, but will then be docking with the station's Harmony module instead of pulling stunts in low Earth orbit. The maneuvers themselves will be made to point the solar arrays towards the sun and then make some star measurements to align the inertial navigation system, which helps with manual flying, even though the primary mode of the vehicle is an automated system. Everyone involved seems to be excited to finally get Starliner crew tested, a goal that has been blocked by a series of issues and delays. The most recent delay was caused by the ISS having such a packed schedule that the Boeing team had to push from April to May, for instance. But other more notorious issues have raised a lot of doubts about the capsule. The 2 previous orbital test flights were marked by several issues. OFT-1 didn't even make it to the space station. OFT-2 had software issues that almost stopped a proper docking procedure. Then there were the hardware issues, one of which was an embarrassing mix-up using the wrong type of tape to secure the wire harness inside the capsule. The engineers had to remove over a mile of the flammable tape. The team seems to have sewn up all of the major issues with the extra time they were given, however, and the last bit of certifications will be happening over the course of this month as Starliner is joined to its Atlas V. Let's hope no other failures or delays manage to stop the Starliner this time. NASA and Boeing have certainly waited long enough to see what this vehicle can do. NASA is on the path to resolution of a computer issue that had crippled the Voyager 1 probe since late last year. At a meeting of the National Academy's Committee on Solar and Space Physics, Joseph Westlake told the assembled scientists that his team had found a possible method for fixing the glitch. Westlake is the director of NASA's heliophysics division, where the controllers for both Voyager probes work, and while he couldn't guarantee that this idea would work, he did say that he thinks the team is going to get to a point where Voyager 1 is going to continue alive and kicking in space. The problem started back in November when the regular data transmitted back to Earth by the probe was found to be completely unusable. NASA technicians took some time to look through the potential causes and concluded that the issue was likely the flight data system computer, whose whole purpose is to gather the data from the probe's instruments before it is sent back to NASA. But it wasn't an easy fix at all. The biggest problem being distance. Voyager 1 is over 24 billion kilometers away, meaning communications take 22.5 hours to ping back and forth. The other issue is that the Voyager probes were built in the 1970s, so all the original engineers are not exactly able to help. So the technicians had to dive into the 50-year-old technical schematics to find a solution, and after a couple of months, they did. On March 13th, NASA announced that the team had been able to send a poke command on March 1st and had received some strange readings that differed from the garbled mess that Voyager 1 had been sending back since November. After a bit of decoding, engineers found that this data stream contained a readout of the entire FDS computer memory. The poke had worked. At the time, they still had some work to do in order to figure out exactly what was wrong, but by comparing this new data to the older transmissions, the team was able to piece together the real problem, a hardware failure. Westlake explained that a part failure on one of the memory units had caused the problem, and so the team would now have to find a way to move a couple hundred words of software from one region to another in the flight computer. Westlake didn't elaborate on how long this would take, saying that creating a solution and then putting it into action would take time, but it's a bit of real hope that NASA could be able to keep the old spacecraft operational. On February 21st, Varda's tiny W1 capsule landed in the Utah desert after spending 7 months in space cooking up some important drugs. Ritonavir, an antiviral HIV/AIDS medication, was successfully crystallized in orbit, a version which was made automatically and then survived the fiery plunge back through the atmosphere to be collected. Them space drugs cooked up real good, said Varda Space co-founder Delian Asparov via his social media account on X.com. Varda's goal was to get data on the feasibility of growing pharmaceuticals in microgravity, which they believe could eventually prove cheaper than ground-based methods and help lower the cost of many life-saving medicines. The capsule also managed to snag a good amount of data on how launch and re-entry affects the production process, and everything was published in a study for use by anyone in the industry. According to the paper, the Varda team was seeking to provide a detailed experimental dataset to pave the way for in-space processing of medicines that we need not only on Earth but also for any attempts to explore deeper into space. The success of growing an HIV drug in orbit proves that Varda's method of uncrewed pods could work as a viable alternative to expensive orbiting labs, making the whole process much more cost-effective.